Welcome, it's Miss Skelton here, and this video is going to help you know what y-intercepts are, and then how you can find them on a graph, in a table, and also from an equation. So you've talked about intercepts before, and we've mentioned them so far in our class, but I want us to define them and then see what patterns we can find about them. So most of the time, or probably the one you've spent more time on before, is the y-intercept. So a y-intercept is just the point where a line reaches the y-axis. Okay, it is an ordered pair, and it also has a special pattern. So every point on the y-axis, to get there, you don't have to move to the left or the right at all. So the x value is always 0. Y value is always a number. So anytime you see y-intercept, you know, okay, the x is 0, the y is going to be some number. Also, I want to remind you that it's b in y equals mx plus b. So if our equation is written in that form, I know the y-intercept right away by looking at the b value. X-intercepts. So it is the point where a line reaches the x-axis. I know I'm making it sound singular, like I said x-intercepts here, really it should be like a point where the line reaches the x-axis. We're going to see next semester there are certain graphs we study that have multiple x-intercepts. Quadratic graphs, we've actually already talked about them a little bit. And of course I could draw some random shape on a graph that will have multiple y-intercepts and multiple x-intercepts. So for an x-intercept, if you think about any point on the x-axis, I have to move on the x-axis to get there, but I'm never going to have to move up or down. So as an ordered pair, the x is going to be a number, and the y is going to be 0. We're going to be really specific when we answer the x and y intercepts today, because we need to specify it as an ordered pair. Not just say one number, but tell me the whole coordinate of the point where the graph reaches one of the axes. Okay, you know before we said B is y-intercept. Well, if we're in slope-intercept form, we can't tell what the x-intercept is. So we'll get to that at the end of this video and talk about what our options are for finding it. Okay, let's look at some examples here. Find the x and y intercepts and slope. So we're going to review from the first video. So let's start with the intercepts. Okay, the x-intercept of this graph, I want to find the point where it reaches the x-axis right here. So that ordered pair is -2, 0. I see the x value is a number other than 0. It's possible it could be 0, 0, and the y value is 0. Let's look at our y-intercept. So find the point where the line reaches the y-axis, and that's the point, I know that x is 0, that's a guarantee. 1, 2, 3, 4. So instead of just telling me 4, tell me it's the ordered pair 0, 4. And now let's review from the first video about slope In a graph, we can do our rise over run, so let's practice that. I'm going to start at the point on the left. I have to move up 1, 2, 3, 4. So it's a positive 4 over 1, 2. And 4 divided by 2 is 2. So slope, we count the rate of change. The x and y-intercept as a single point. Each one is a different point here. Okay, B. I know the graph didn't turn out great, so hopefully you can kind of tell. Let's label where our y-axis is. And then if you see this kind of like extra dot here, that's supposed to be the arrow of the x-axis. And then we're looking at this line, which is the darker part. So hopefully that helps as you're looking at this example. So let's start with the x-intercept like we did before. Where does this horizontal line meet the x-axis? Well, hopefully you're trying to tell me through the video, never. They're parallel. So it's okay to not have an x or y-intercept, or x or y-intercept. So this x-intercept would be none because this horizontal line never reaches the x-axis. Let's look for a y-intercept. So I do see that this line reaches the y-axis. It looks like at 1, 2. Instead of just writing 2, though, I'm making it an ordered pair. The x is 0, y is 2. And then remember what we said about slope. If I have a horizontal line that's not increasing or decreasing, its slope is 0. If you try to count rise over run, you don't have to go up or down at all and would only be moving to the left or right. So slope of 0 for every horizontal line. Just another. Okay, we need to know the pattern of the ordered pairs for x and y-intercepts to help us with the table. So if you know that all y-intercepts look like 0, a number, and x-intercepts have a y value of 0, it'll make it really easy for us to find them in a table. I'm going to stick with the x-intercept first, just like I did above. I'm looking for a place in the table where the y value is 0. So I see it right here. Y is 0. That pairs with an x of 1. So the x-intercept is 1, 0. Okay, let's look for the y-intercept. So look where the x is 0. And I see 0, -5. That's the y-intercept. And then remember for our slope, our rate of change, let's do the change in the y's over the change in the x. And you get to pick. So I'm at the bottom here, from 5 to 20, I have to add 15. So the change in the y's is 15. And then when I look at the x's that pair with that, from 2 to 5, I had to add 3. So we're going to divide by positive 3. 15 divided by 3 is 5. So the rate of change here is 5. The y's go up by 5 every time the x by 1, like we see in the middle here. Later on, we saw this bigger change in our y's and in our x's because it's skipping over some of the x values. It skips from 2 to 5, and that's why we saw a bigger jump in the y values. No matter which points we pick, we're going to see that the slope is 5. Okay, so let's try B, and again, I would pause the video, try it yourself, and then tune back in to see if you're right. pause and see. Okay, hopefully that helped. So now I'm looking for where the x is 0. I see 5. So that's my y-intercept. So x and y-intercept are just ordered pairs. I'm looking for a 0 in the opposite variable. So x-intercept, the 0 for y. Y-intercept, 0. Let's find the rate of this table, the slope. So I'm going to do the change in the y's over the change in the x. 8 to 10, I'm adding 2. So change in the y is 2. And 6 to 10, I'm adding 4. 2 over 4, and then let's reduce that fraction. So dividing the top by 2, I get 1. Dividing the bottom by 2, I get 2. Remember, the calculator could help you reduce if you were struggling. So slope is positive half. So far, we haven't really had to show much work at all. We were able to find the intercept by looking for points on the graph, looking for special ordered pairs, and the only time we may have to show our work to figure this out is when we're finding x and y intercepts from equations. So A says find the x and y intercept from the equation, and then it gives us one in standard form, 3x minus 2y 6. I know that in the first unit we spent a lot of time getting y by itself. We don't actually have to here. So we're going to use what we know about intercepts. I'm going to start with the x-intercept like I have been for all the other ones. In every x-intercept, we know that the y is 0. So we can use that to find the x-intercept. We are going to plug in 0 for y and solve for x. So in this equation, I have 3x minus 2 times 0 equals 6. I replaced the y with 0 because I know the x-intercept has y of 0. What's 2 times 0? 0. So I'm just solving the equation 3x equals 6. And when I divide by 3 on both sides, I find that x is 2. And so the x-intercept, let's write it as an ordered pair just like we have above. The x-intercept is 2, 0. I know the y is 0 because that's true of every x-intercept, and we put 0 in y's place. Okay, so I bet you can guess how we're going to find the y-intercept. Plug in 0 for x, since I know every y-intercept has an x of 0. And then we'll solve for y. So back in your original equation, I'm going to plug in 0 for x, 3 times 0, minus 2y equals 6. 3 times 0 is 0. And so all I'm left with is negative 2y, that sign is still there, equals 6. And when I divide by negative 2, y is negative 3. So now I know my y-intercept is 0, negative 3. So we had to do a little bit of work, but it's not hard. Plug in the 0 for the opposite variable, it's gone, and leaves us a one-step equation to solve. Okay, so notice that one was in what we call standard form. We're all about the forms next class. So standard form, where y is not by itself. Now, if y is by itself, think to yourself, which intercept do we know? So currently, the way this is written, I know M and B. So I know the slope is -2. And I actually already know the y-intercept. So that's the point 0, 5. I'm going to show you that you could still do the work by hand here in just a second, though. Okay, so let's look at the x-intercept. We're going to follow the same steps. Plug in 0 for y. So when I write this equation, I'm not going to write y. Instead, I'm going to put 0 equals -2x plus 5. And now we need to solve for x. Okay, this one has one extra step because I have to subtract 5. -5 equals -2x. I need to divide by -2. And -5 divided by -2, you could leave it a fraction 5/2, or you can tell me 2.5. We may want it to be a decimal if we were going to graph it, because I know where 2.5 is, but it's harder for me to visualize where 5/2 is for some fractions. So our x-intercept is 2.5, 0. Notice I didn't box the 2.5, I wrote it as an ordered pair. Okay, we said that we already know the y-intercept, but I want to show you how we could still plug in 0 for x and get the same thing. Okay, so I start with y equals -2 times 0 plus 5. Sorry, ignore that. So here, when I do times 0, that's 0. That part's gone. And all that's left is y equals 5. So these steps will work all the time. It's just if my graph is in slope-intercept form, y equals mx plus b, then I actually know the y-intercept from the beginning. Okay, so hopefully this has been helpful to find your intercepts and still review how to find your slope. We're going to keep working more on this next class and all unit long.